and the average value of all even integers that are divisible by 3. The probability of is the sum of the number of Gaussian. Alice, Bob, Alice, Chris. 1, 2, 3, 4. Alice का ID 1 then it has views 5. Ska ID 3 then it has views 5. 5 is 10. Bob has only 10. So, okay. 1 is returned because O comes before D. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, Q, R, S, T. O comes before 3, yes. D. Then Chris is not something we are expecting. Okay. So, what I can do with Alice is I can have my key as the creator. And then the number of views. From that, I'll get the creator which is most popular. Now for ID, for each creator, I can store the ID as well. Okay. So, frequency. Here's my creator. Let's say the name of the person is creators of I. ID is ID is IDs of I, and then view is views of I. So new frequency info is frequency ID is info of ID is this, and then info ID of name dot append ID. That's it. So max uses maximum of frequency of use dot values items use. In that case, or I could even say answer append minimum of minimum of ID of this key and answer. Alice 1 Bob 2 Alice B, Alice 1 Bob 2 Alice A. I'm getting, but expected was B. Why is that so? So the view which is having the hmm. instead of appending the unique ID now, I can simply append this, the number of views associated to that and the ID. So that way I just need to get the value now. So let's say the array would be ID of name, but again I'll say array dot sort, where in reverse is equivalent to true. So the max value is array of 0 of 0. Let's say candidates for value in array. You can say if value of 0 is equivalent to the maximum value, candidates dot append the ID, right? Else I say okay, break, and now runtime error, candidate is not defined. Okay, Alice B Bob to Alice 1. Okay, let's submit this. Okay, minimum addition to make integer beautiful. Okay, you are given two positive integers n and target, and n and target. An integer is considered beautiful if the sum of its digits is less than or equal to target. An integer is considered beautiful if the sum of its digits, okay, is less than or equal to target. Return the minimum non-negative integer x. Return the minimum non-negative integer x such that n plus x is beautiful. Okay, so I have to add something to n, and it's going to be a non-negative integer, so it can't be, I think so, 0, right? Such that if this was maximum, it would have been great, but beautiful. The input will be generated so that it is always possible to make n beautiful. So n is 16 and target is 6. 6 plus 1 is 7. 4. Okay, initially, so 4, right? So 16 plus 4 is 20, and 20 to 20 sum is 2 plus 0 is 2. 2 is less than 6. Okay. What if I add 1? That's 17. No, not required. 2, that's 18. 3, 19. 9 plus 1 is 10, greater than 6. For 4, initially n is 16 and its digit sum is 1 plus 6 is equivalent to 7. Okay, so if this is already smaller than equivalent to target, then I can even have answer 0. Okay, so 0 is also a non-negative integer, something which has no negative sign behind it. So here I could have also added 5, which makes this 21. Makes this 21. 2 plus 1 is 3. 3 is less than 6, but again 4 is a better answer because it's minimum. N is 467 and target is 633, right? So okay, so we add 33 in here, which kind of makes this as 6. So initially I'll find out, okay, what is the value here, and if the current value is less than equivalent to 6, then it's all good. But If it's not, then I have to I have to make this smaller. I have to find out smallest value of x, right? I don't have to minimize n plus x, but I have to minimize x. If I minimize x, automatically n plus x also minimizes. 4, 6, 7, right? Is the key here to, that key here is to make one of these guys 0. That's it. So, uh, so what if this is 7? Then to make it smaller, I know this is not satisfying first of all. First of all, this is not satisfying. So if I have 1 here, then it will automatically increase this n value. So it's better not to have something like 1, 2, but I can have something like 3 here because it's going to make it 0, right? And 1 carry forward. Once 1 is carry forward, 3 comes up here and again it makes it 0. Something like that should happen. And it's going to be 10 to the power of 12, right? So 10 to the power of 12 would be what? It's going to be something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So even if I had a number like 2 here and then 1 and then so on. So I have to try here maybe 7 possibilities, then go here, carry forward 1. I have to try again maybe 7 possibilities, 6, 5 or 8 possibilities and then so on, right? So it won't be a very big thing. That's going to be 12 multiplied by, let's say, 9 possibilities. That should be the ideal time complexity here, right? And that's going to be roughly 120. Let's assume this is 10, so big O of 120 should be so let's say I am at 16 and I know already this is 7, which is greater than 6. So the best way to minimize this would be not trying something like not trying anything which is going to make this range from 6 till 9, right? So I don't need to try 1, I don't need to try 2, or let's say something like 3. That's it. I need to start with at least 4, which is nothing but I need to start with at least 10 minus 6. Is this more like I need to have something like 1 here, then I'll try with 1 here. Try 1. So for let's say 467, I could say key, let's try 1. Then for this one, let's try 1 here. And then let's try 1 here. Notice if the value was the maximum, even in this case, a simple 1 here will make this 1000, which is really great. So it's not like x will be greater than n. X won't be never greater than n. So I try this combination and now come back here and then I try with all these things, right? So 1 and then let's say 2. It's a little tricky here. How do I get this done? $150, right? So maybe I can try firstly 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, but that won't do, no? Okay, see, once I know that this value is already greater than, the sum of this is already greater than 6, I'm like, okay, I can't have something like 1 or 2 here. This is eliminated. So let's have simply 3. That's fixed. So this makes it something like this, 470. Now again, I compute the sum here. So I see the sum here is nothing but 470, right? So for 470, it's again 11. 11 is greater than 6. So I'm like, okay, we should not touch here. Let's touch at this place. Again, here I can't have something like 1 or 2 because it's going to make it simply increasing. So let's have 3. So this makes it nothing but this will become how much? Let me get rid of this. 470, but a 3 is added here, nothing added here and here. So this becomes 500, right? Now again, I know this is already sum is 5, which is less than 6, and that's my answer. That could be a way. Okay, what if what if my number is 127, right? Or let's say 122, and 2, 2, 4, 5. Let's say the value given here is 3. I need to have values less than 3. So what can I do? I know already 1 plus 2, 3 plus 5. 5 is greater than 3. Hence, I can't have some values like 3, 4. I can't have any values like 1, 2, 3, 4, 5, 6, and 7, because this will automatically make this a lot bigger, right? So it's better to have something like 8. Let's say I will have 8. Now what will 8 do? If I add 8 here, this will become 130. Now again, this is not satisfying the condition. So I will say that, okay, here I can't have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, but I can have 7, right? So this will become 200. Now the smallest number here would be 78. That could be a way. So let's have 122, right? And then I want to have this as 3. So the answer should be 78. Let's simply write 78. Yeah, expected answer is 78, and my answer is also 78. Okay. So firstly, I will say that, okay, check if it's possible or not. So total is 0 for value in str of n. I can say total plus equivalent to integer of value, and then if total is less than equivalent to the target, in that case I return 0, else I go on to find the number which is the smallest x. So let's say the number would be initially 0, right? Now what can I do here? I can start from the very end. So for how to start from the very end, it's very, very simple. Well, this is going to go for at max that many times, right? So times is 0, or let's say, yeah, times is 0, while times is less than length of str of n, right? Yeah, while times is less than length of str of n. I am at the very last value, so here I can say my this will be a great approach. So my value is integer of what? N of or let's say my n becomes str. No, leave the n as it is. Let's change this to temp, which is str of n. Um, List of str of n, that will make sense. So it's going to be int of temp of idx. That's it. So my current value is the very last value in the temporary list. And now my n value will change accordingly, right? So will the temp value as well. So I need to get it to 0, right? The thing here is key. What if I had a value like 98? Better thing would be 2. So this becomes 100, right? 2 is the smallest value, that's it. Hmm. Mhm. Whatever happens, this is always going to take a carry of 1, right? I can't rule over that. So that will make sense. Now, how do I get that value? If the value is 8, then I need 2. So it's very simple. Needed is 10 minus value. That's it. So right now I have needed. No, I have needed. Mm, what if it's 0? Hmm. What if it is 0? Something like 190 and the value is 5. I need to be having less than 5. So what can I do in this situation? In this situation, I have to have 0 here. Like there's no chance I can get rid of this. So I have to have 0 here. And now here I can have 1. So this will make it something like this, which is good. So 10 is the answer here. So when it's 0, I just simply need to have as it is, because 10 minus 0, 10 never makes sense. So I can even say here that if my value number को string में डाल सकते हैं, right? Yes. So if my value is equivalent to 0, in that case number plus equivalent to 0, else my needed is 10 minus value. Also my carry currently is 0. It's really neat, important to note that. And needed has been taken. I can say number plus equivalent to what? uh, str of needed. That's it. Now I just simply need to check like how are these numbers changing. It's 98, so 2. Carry is 1. Now the current value is 9 plus 1 is 10. Hmm. So is this not more like that linked list problem, wherein if it was 89, I have 2 here, then carryover gets there, and this probably becomes what? Sorry, 0, and then 1 comes up here. Then so I add 2 here, right? So this becomes 0, followed by 9. So 9 में carry था, so this also becomes 0, and this becomes 1. That's it. This is more like that linked list wala hi problem, but let's see. Then I reverse it, I get the number back, which is 100, and then I check, okay, this is less or not, and then done. Also, I don't need to reverse it, it's simply sum of the numbers, of the digits, sorry. Okay, I want to like simplify this. So let's say my number is a string representation of n, and it's reversed right now. So something like let's say 1 2 3 looks 3 2 1. Now for index in range length of number, what I need to do is, I know right now that if, okay, क्या करना पड़ेगा अभी, carry is 0. If so my current value is what? Number of I, but I'll do an integer of that, and number of I integer of that plus carry. So right now this becomes what? Some value, right? Now if my value is equal to 0, in that case, to my answer I'll add this. Else, let's see what we can do. Else I know my needed would be 10 minus the current value. So 10 minus, let's say, 2 8, right? So with that in mind, I need to reform my number, my original number. So I also say that my temp is number of blah blah. I do a little temp of I here because, yeah, temp of I. So right now I can say that my temp will change, right? So let's have the new temp as get number, and I'll pass in my temp here and the value needed in the index as well, right? That's it. So if it's 98 98, then I'm adding 1. So I'm passing what? I'm passing in 98 needed, which is 1. Let's say this is 78. I'm passing in needed, which is 3, and index is 0. So how do I get it to something like 90? How do I get it to 90, which is 09? Let's see. So right now, let's say it's 78 and needed is 3, and this is IDX is 0. So I need to form 09 correctly. How do I do that? Start from that current index only, right? Or I in range IDX till length of temp carry is 0. So I can say my current value would be carry plus temp of I, but an integer of that, plus needed. By the way, if I is equivalent to IDX, just the very first step, then I'll do that, else I'll do this. So I can say new number is going to be temp of previous till IDX, right? Yes. And then here I can have new number plus str of value. So I can simply say carry, my new carry would be what? So let's say my value turns out to be 10, right? So let's say my value turns out to be 10. In that case, carry would be what? 10 by 10, right? So that would be very simple. If my value is equivalent to 10, in that case carry is 1, and I can simply say my value is 0. So new number plus equivalent to str of value. And also I know that that's it, right? That's it. Return new number. So what is this going to return? How is this going to work? 78, right? I is IDX, value will be what? 0 plus int of temp of I, which is 7, plus needed, which is 3. So 7 plus 3 is 10. Now if value is 10, carry is 1. So carry is 1, value is 0. So new number, okay, so in new number, I'll add 0. Then I go to the next index, carry is still 1. So if I is equal to IDX, no, it's not the case. Else value is carry plus 1. So 1 plus 8 is 9. Now if value is equal to 10, no, value is 9. So I come here and I say new number plus 9. So new number will be 9 itself. Okay, what if this was 79 and needed to add 3? So if carry is equivalent to 1, that's an edge case. Yes. So what if this was 79? 3 comes here, gets added. New number mein, it's basically 0 and carry is 1. Now 9 plus 1 is 10, right? Value is carry 1 plus 9, which is 10. Now again value is 10, so carry is 1, value is 0. So new number will become 0, 0. But still carry is there. I have run out of index. So this will be what? 0, 0, 1. which is 100 if you look at it in the other way around. Yes, so 100 comes up here. So temp now becomes 100. So I'll return some answer here, right? And that answer will be something which I will populate here right now. I think so. Well, that answer will be dot join temp itself. We'll see this, and then may I can say return dot join temp. Let's see. Let's see. Answer I don't need here. So get number is going to give me the new number. That's it. Nothing special. Then I just simply need to return temp now. The join temp is even not required. Let's see where are we going wrong here and there. Use example test cases, run code. Runtime error, global number, IDX is not defined. So this is going to be I. My answer is this, right? So I simply need to have the needed value here, right? So that's why the answer thing was there. I'm getting something like 48,334 and then 0, right? Which is wrong. So what's really happening? Let's see. I think so it's going for a very long time, right? Not for value in str of n, this should be temp. So it's giving me 4,334 and then 0. So why is there a 334 here? 467, right? Let's print temp here for this test case. Okay. Carry is not needed, by the way. I guess यहाँ पे carry needed नहीं है. So value is 7 and no, value is not 0. Needed is 10 minus 7, which is 3. Answer may we get 3. So temp is going to get some number. Carry 0, new number is nothing as of now, right? One plus 6, which is 7, right? So 0, 7. So wait, so if I add simply like a 3, then that should round up to 480, right? 467, 467, 470 हो जाएगा, right? So 0, 7 के बाद आना चाहिए simply that stuff, but 5 आ रहा है because okay, that's that. I'll do this. अभी जाके ठीक हुआ. Okay, what about my custom thing? Let's say it was 5. Let's say it was 6. Let's say it was 3, right? 87, which is wrong because I need to return a reverse of this thing. That's it. Let's do that. Use example test cases, run code. 4330, 4330. Let's submit this. Accepted. Beautiful. Height of binary tree after subtree removal queries. Okay. Height of binary tree after subtree removal queries. Height of binary tree after subtree removal queries. So maybe I have to remove subtrees. Okay, you are given the root of a binary tree with n nodes. Each node is assigned a unique value from 1 to n. You are also given an array queries of size m. You have to perform m independent queries on the tree, where in the ith query you do the following. Remove the subtree rooted at the node with the value queries of I from the tree. It is granted that the queries of I will not be equal to the value of the root, so I don't have to remove the root itself. Return an answer, so independent, right? Uh, Return an array answer of size m, where answer of I is the height of the tree after performing the ith query. The queries are independent, so the tree returns to its initial state after each query, definitely. The height of a tree is the number of edges in the longest simple path from the root to some node in the tree. How many, okay, what is the length of the tree? N is this, right? So degenerate tree होगा तो problem है. It's not a height balanced binary tree, right? Or is it? The root of a binary tree, simple binary tree. And queries का length क्या है? It could be m, right? Where m is the minimum of n and 10 to the power 4, okay. So it can go at max 10 to the power 4, not more than that. Yes. Okay. So firstly, this is what the tree looks like. 1, 3, 2, 4, 6, 5, 7. Now the queries is 4. In this case, it's saying ki, okay, remove everything from 4. So 4, 6, 5, 7 all got removed. Answer is 3. Tree of removing subtree, the head of the tree is 2. Path 1, 3, 2. Acha, okay. So height is 1, 2, something like. So it's also depth or height is used loosely, right? Three, 2, excuse me, 4 hटाने से still 3. So what could be a trick here? One thing is key, when I reach a height of okay, so when I reach the height 2, I simply say that okay, uh, let's stop here, this is the end here, so I return back. That's one way, but again, worst case, all the queries are the very last leaf values, then in that case I'm screwed, right? maybe at a particular level I have to keep track of uh, I don't know, is it more like something to deal with the leaf nodes? Okay, how many I can have, by the way? There was a formula, right, which I tend to forgot, but let's say it's 10 to the power 5 nodes. So at the very last level, how many can I have? It's 1 at the first level, 2 at the second level, 4 at the this level, 2 at this, 1 at here. So here it will be fourth level में 8 होगा and then so on, right? So how is this interrelated? I forgot. Now there will 16 of them at the fifth level. So is this not more of like 2 to the power level minus 1? So I'm saying at, and acha, how many nodes are there right now? Till now it's probably 1, 2, 4, 8. Like this, that will increase, right? So let's just do it very stupidly. So some 10k value, right? 10k. Then it will become somewhere around 20k. So I think so the number of leaf nodes, I forgot this. So R is that multiple, right? Yes, it's the same thing. So but again, that won't do me any good because um, let's say even if it's 10,000 leaf nodes, right? Then I have to go over all those 10,000 leaf nodes and then again, uh, apparently like 10 to the power 4 So for each leaf node, again, a logarithmic time, right? Log n. So it's kind of like 10k log n multiplied by, for each query, let's say 10 to the power 4 queries. Just quite big. But that could help me out actually. So what I am thinking is that if the tree is like this, right? Then at every leaf node, I will find out how many, yeah, so like how many, what is the depth till here, right? What is the depth till here? Depth till here and till here, right? So if the depth till here is x, this is y, this is z, this is a, this is b, and I know I'm removing some node like this, right? So from x, I can simply traverse up. That's gonna take log n time. From here, I can just traverse up. If I see it's blocking, this is not an answer. I traverse up, this is blocking, this is not an answer. Let's say I traversed up and A was one possible thing and B was one possible thing. I'll take the maximum of both of them. Okay, that could be a way here, right? Okay, what I can do is, if nodes is this. First of all, I have to get the parent, right? Get parent, root is something I provide. So let's just quickly write that function. The root of the tree. Now I can say my parent looks like this. Q is, let's use dq from collections, better. Okay, now, so if not root, return parent. Q dot append. What I'll have here, I'll have something like root and then the value 0, and then I'll say while q, so my current node and height is going to be q dot pop left. Now I can say that, okay, if node dot left, then in that case q dot append, I'll have nothing but like node dot left and height +1. That's it. Hey, I'm not doing, acha, I could also do that in one go only. Yeah, I can do that, right? So instead of having, acha, leaf nodes is this. So this parent is going to hold like very good bunch of information. So I can even say leaf nodes in here itself. That's it. So if node dot left, then q dot append this, and then I also say that, okay, parent of node dot left is nothing but node itself. If node dot right, so my right child like this, q dot append node dot right, and then height +1, right? Beautiful. I also say that, okay, my parent of the right child will be the current node itself. But what if I figure out that this is a leaf node? In that case, I can simply check in this way. If node dot left is none and node dot right is none, then I know this is a leaf node. So in that case, leaf nodes dot append. Apparently I'll have the node itself and the height. That's it. So I also get the leaf nodes information. Then I return back, I guess, my parent and the leaf nodes. That's it. So this is not really getting parent, but get parent and leaf height. So this is like leaf node information. That's it. Right now I have the parent and I have something like leaf height as well. So here also I need to return this and this. That's it. Hmm. So right now I have this. What I can do, I can just simply loop over the queries. So for I in range, then queries, yes, and queries. My current node value is queries of I. Now I need to get this as well, right? So they are giving the integer, not the entire representation, because see, queries is a list of integer, it's not a node. Okay, never mind. Now I have a particular node, and let's say this is also a dead end, right? Let's call this as dead end, right? Dead end. Now I need to loop over all the leaf nodes and find out if they don't have a dead end. So here I can say max height is going to be, says 0 initially for value in, or let's say for j in range length of leaf nodes. What is my current node and what is my height? So that's going to be leaf nodes of j. Now simply go up the parent tree and find out if the current node leads to dead end, right? So while node is not equivalent to dead end, but also the values are scattered. It's not like while node in parent and node is not equivalent to dead end, I'll say node is equivalent to parent of node. That's it. If node is not equivalent to dead end. In that case, max height is equivalent to the maximum of previous max height and whatever the current height was. That's it. And end of the day, I'll have to have an answer, which is this, and here itself I can say answer dot append my maximum height. And then I'll have to return the answer as well. This is giving me 3. There are a bunch of 3s, which is absolutely wrong. So so if node so while node in parent and node dot data, right, or node dot val is not equivalent to dead end, and if node dot val is not equivalent to dead end, then this happens. Run code. So this is giving me 32323 and kind of fine, right? Yeah, let's submit this. We have a wrong answer. Their expectation was 1, but here I had 0. So I guess whenever there is only one thing, the height is always that, right? So whenever there is only one root, height they are assuming is 1, I guess. We have answered wrong here. Okay, that's not the case. Okay, what is this tree, by the way? This tree is this one. 1, then null, followed by 5. Then null is null itself. For 5, it will be 3 and then null. For 3, it will be 2 and then 4. The queries are as follows. Excuse me. So for the query 3, if 3 is removed, height is 1, which is obvious, right? Oh, okay. So I need to, what if my max height never gets initialized with any value? So I know everything, like everything kind of boils down to this dead end, right? So we are never getting an answer for 5. How do I get an answer for 5? Very trivial way would be to get it from there only, yes. Hmm. Hmm. So this is also going to return rest of the other nodes. Other nodes as well. So what if my max height was -1 itself after all of those things? So if max height is equivalent to -1, I know that this dead end is a very special case or an edge case. So I can say simply max height will be other nodes of dead end. That's it. Dead end. That's it. So in that case, 1 should be the value here, right? Yes. So let's quickly see for this test case. It should be 1 0 followed by a bunch of 3s. Rest node, where is it? What's the problem here? Rest nodes. Sorry. Run code. Now it's giving me 2133, but let's see again what's the problem. So 3 is the thing, no? So this should be what? It's -1. That's it. Now it's fine. Again, if I just do the example test cases as well, it should work fine. See? 2 3 2 3 2, right? Submit this. We have a problem here. Okay. So they expected for 3, they expected this thing, right? So 415, let's see this example. So it's basically 4 1 5. For 1 it's null and then 2. For 5 it is null and null. For 4 it's 1 5. For 1 it's null and 2. For 5 it's simply null and null. For 2 it's null and 3, right? So it's basically like this. So if I get rid of like 3, then the maximum height I can have is 1 2 2, right? So they expected 2 and I'm not giving the answer 2. Why is that the case? Let's see. So in this case, my node is basically that value itself. While node in parent, yes, it's in parent, and node dot value is not equivalent to dead end. But it's equivalent to the dead end value, right? Which is 3. In that case, I say node dot value is not equivalent to dead end. Backside is this. Let's print leave nodes and let's print parent here. Let's also print other nodes for this test case only. So what I printed firstly is leave nodes, right? 5 and 3. So by the diagram it looks like that only, right? That's 1 height, that's 3 height, right? It's 1 2 3. Yes. Now this is more like 1 is assigned to this value 2 and 3. One, 2 and 4 are the other nodes. Definitely, because like 1, 2 and 4 are the other nodes because they are not the leaf nodes. Logically, it should give me the value 2, right? While node in parent, yes, it's there, and node dot val is not equivalent to dead end. That's true. So if it's not equivalent to dead end, I see. Hmm. Hmm. Also, if node dot val is equivalent to dead, kind of like an edge case. Don't know. Let's see. Submit it. There might be time limit exceeded. 30 test cases. Okay, what if I did a very simple approach wherein like, let's say the height here is x, height here is y, height here is z, height here is z, right? This is also z. So this will hold, hey, I got x from here. This will hold, hey, max I got from here was z. And this can hold the max I can get from any one of these people or x. So let's say I come here and say that, okay, let's say this one, right? I want to remove this one. So On that note, I can say that I'll just traverse this level, right? Just traverse this level and leave this. Check that, okay, hey, how much is this height giving me? This is giving me Z. This is giving me Z. This is giving me Z. Maximum of these three is, like, answer will be Z itself. It can be done. I don't even need to do all of this. ओके, लीफ नोड से एक चीज़ कर सकते हैं. दैट्स इट. सो फ्रॉम 3 आई मूव टू 2. 3 में क्या स्टोर हो गया कि इसका हाइट 100 है. 2 में क्या स्टोर हो गया कि इसका हाइट अभी मैक्स 100 है, एंड देन सो ऑन, राइट? So when it came to root, I know I can't do any stuff here, right? So root पे I don't even need anything, I guess. Or do I? I can handle that case. Okay, that's done. Let's get rid of that. Also, I don't need something like an other nodes from here. Other nodes I don't need. Leaf nodes I need. Parent, do I need? Yeah, parent I need. Parent I need. Other nodes I don't need, right? So I can get rid of that real quickly. Rest nodes I don't need at all. Leaf nodes are fine. Now what I can think here is key for each query. I'll also have to do a level order thing, right? I'll also have to do level order traversal here. So level order I can get from here, maybe. So apart from this, I have something like this. Starting with root. Yeah, root can be there, right? Or better would be that, hey, this root is at which level? It's at this level, something like that. So root is at the level 0. That's it. Root dot val is at this level. Level root and then level values. So at 0 we have root. Several nodes of this right here. So node dot val. And with that node I can have the value na kitna height hai. Beautiful. So okay, I'll do this later. I can't